Good evening, everybody, and welcome to another episode of vBrownbag. Tonight, we are continuing our series on Azure, and I am very excited to have Nick and Cooper on to talk about Azure Automation with ARM and Terraform. I've been eagerly awaiting tonight's presentation for a little bit because automation is near and dear to my heart. So before we get started, let me bring up a couple of little quick housekeeping notes. Get in on the conversation. I will be monitoring the live webinar feed, the attendees in the audience, as well as watching the @vBrownbag and #vBrownbag Twitter feeds online on the Twitters. With that, tonight our guests are Nick Colyer. He is @vnickc. Nick, did I pronounce that last name right? Is it Call?
You've got it, yep.
Okay, thank you, sir. And Cooper Lutz, he is @Lutz_Cooper. Feel free to irritate them during the webinar via Twitter. If they have not just turned off their notifications, we will find out soon enough. Again, I am Chris Williams, and you can bother me @Mistwire. And with that, Mr. Colyer, let's kick over presenter to you.
All right, sounds good.
Cool.
Show my screen. Let me know if you can see it.
I can see your screen, sir, yes.
All right, perfect. So yeah, well, first of all, thanks Chris and the Brownbag team for having me on again, and pretty excited for today's. Automation is dear to my heart as well, so I was pretty excited given the opportunity to come and present this, especially with Cooper here. So we'll do some quick introductions for ourselves in a second, but just to kind of let everybody know what the agenda is for today. Really, this is focused on Azure Automation with ARM and Terraform. We originally were just going to do it on ARM, and then just given the wave of Terraform adoption, we thought we'd just kind of combine the two. And so this is kind of a half and half overview on ARM, half quick overview on Terraform as well, really focused on infrastructure as code. So I'll do an ARM templates overview, then Cooper will give us a demo. I'll do a Terraform overview, and then I will do a demo for that as well. So with that said, some quick intros for
Nick,
us. So brief
Nick, real quick.
Yeah.
Your screen is looking at your prep screen, not your main screen.
Figure that out. How do we fix that? You know what? Let me just do duplicate on here so we don't.
You can flip it over. There's an option if you blow it up.
Yeah, let me hit that actually.
There you go. Yeah, at the top there you go.
There we go. Sorry about that. There you go. Yeah, are we good now?
Oh yeah, perfect.
All right, perfect. So yeah, brief background on myself. So I'm a solutions principal and I'm the Azure practice lead at Ahead, which is a value-added reseller out of Chicago. Also work with Cooper there. So we've done a lot of Azure projects together. I'm also a founder and instructor for Azure at Skyline Academy. So the Brownbag team very kindly allows me to do a shameless plug and throw a coupon out for everybody to get some discounts on our courses. I blog, I've got a lot of experience in kind of AWS automation, but I was more passionate about Azure, and that's where I've kind of moved my career to. If anybody does want the Azure training or the Terraform courses, it's vBrownbag50 is the code, and you'll see all those courses on at skylinesacademy.com. Feel free to use that. I'll throw it up at the end as well. But I'm very excited to introduce Cooper, I've had the pleasure of working with over the past year here at Ahead. Cooper, I'll let you kind of introduce yourself.
Thanks, Nick. My name is Cooper Lutz. I am a Azure engineer at Ahead. Work alongside Nick. I have a blog of my own, cooperscloud.tech, where I'm generally talking about Azure-related topics. I have a very focused on Microsoft technology type background. But Azure is really my passion and main focus. That's me.
Okay, awesome. And very quickly, I'm going to pull up Cooper's blog because there is something on there that I think will be really useful if you still have your series going. Let me pull this up real quick. So Cooper does have this whole series on mastering ARM templates, and just given this whole Brownbag today was an ARM templates. There's 1, 2, 3, so I highly recommend. If you want to get more into it and learn more, there's 3 blogs there that you can kind of read about. So
very cool.
All good stuff, relevant stuff. So so the automation technologies. I'm not going to have to do this every time. Let's just duplicate slideshow here. There we go. The automation technologies. I thought I'd bring this up first of all to talk through, because there is so much confusion, I would say, just given all the services Microsoft are adding to the Azure ecosystem around automation. So just understanding what each one of these are and what they're used for, I think, is very important. I think we will loop back around and cover some of the others. Today, we're definitely focused on ARM and Terraform, given where this brown bag is going. But let me just kind of tell you what each one is for, in case you're wondering, when do I use which? Why should I look at these others if I can kind of do everything in ARM or Terraform? Well, ARM and Terraform are really mainly focused around provisioning and the infrastructure as code technologies, which we'll get into what that means, in a little while. Logic apps are essentially Microsoft's kind of if this, then that type flow. So they're more reactive applications. So if somebody posts a tweet and you want an app to do something automatically in response to that, a logic app's a good way to do that. Or something happened in Azure, I want to notify my change control system that this event occurred. Logic app is where you would use something like that. Azure Automation, think of more like, vRealize Orchestrator. Think of it like, even to some extent, think about automating your PowerShell workflows is a good way to think about it. Stitching together multiple things, that's where that really comes in. Azure Functions, if you're familiar with AWS, are really your equivalent to Lambda functions that are there. So you can take various scripts and code and run them in response to an event, or just periodically, or you could essentially take a whole entire application and turn it into a Azure, or decouple it into multiple Azure functions. And then the last two on the list there, API, PowerShell, those are other methods you've got as well. So you can just talk directly to the Azure API. There's a whole bunch of PowerShell commandlets. There's an Azure CLI, plenty of choices. Those are more for, administrating the environment, or perhaps, the API, if you're building an application that's going to build Azure services, is where you would use those. But again, for right now, we're going to sort of, dive in here and hit ARM first, and then kind of, move on to Terraform as we go through. So you might be asking, well, where did all this come from? And I always like to start with the slide, because I always think of this as the traditional IT service request process, right? A developer used to put in a request, and it was almost like this archaic thing of the scroll that gets kind of passed around between teams, and everybody's got their task, but everybody, you're sort of handing off this information from one team to another until everybody gets their task done. What infrastructure as code is really an answer to that, right? It's a declarative way, as you'll learn more about throughout this, where I say, I want to build something, and this is my piece of paper that says how it's going to be built. Just go and do that. Don't ask somebody to go and do a task. Don't pass a ticket around. Don't pass this piece of paper around. Let's just kind of go ahead and get started and build straight away. And that's really the focus, is on infrastructure as code. When we look at Resource Manager specifically, there's four main constructs that you'll kind of hear about here in Resource Manager. And starting from the left, you've got your resource in itself. This is your individual manageable item that's available to you in Azure. You've got resource groups that you're probably familiar with when you build something in Azure. This is like your container, not to be confused with Docker containers and everything else going on in that ecosystem. This is just a container where you can place your resources. So typically, you will want to share, service resources that have the same life cycle. You would put them in the same resource group. If you've got resources that are on different life cycles, like your Active Directory servers and your Palo Alto intrusion detection system, you wouldn't put that in the same resource group. They would be typically in separate resource groups, because when you delete a resource group, you can delete all the resources inside there as well. Well, the key to all of, as you consider the resource group, you then have resource provider. And this is really whenever Microsoft releases a brand new service into Microsoft Azure, they create a resource provider. So, if you're trying to build virtual machines, you're going to see things in the service of Microsoft.compute. There's storage, there's all the different services that you have there. And so this is the mechanism, and you'll see actually Terraform uses a lot of this concept as well, is that, as long as I understand, okay, every time I want to build something, it's coming from a provider. The provider is basically how the Azure Fabric knows what to provision. Then I will learn more easily how to automate. So definitely sort of become more familiar with these. And Cooper, I believe you're going to kind of show some of that in in the demo a little bit later on. And then ARM templates, these are the files we use to define resources we wish to deploy into a resource group. So again, kind of resource group, provider, ARM templates. It'll become clearer and clearer as we kind of go through. So, so the ARM template itself is a way of applying infrastructure as code. For example, you'll see in the screenshot here, probably a little hard to read on the share here, but this is an ARM template purely for creating a storage account in Azure. If you saw the storage brown bag we did a few weeks ago, we created a storage account. Instantly that's 5 petabytes of space available to you at the click of a button. That's available to you, but instead of us going through the GUI like we did a few weeks ago, this code would essentially create that. The key thing to note is you can download a lot of templates from the Azure portal, which we'll show you some of the demos here. You can author new templates if you want to, but more importantly, there's these quick start templates provided by Microsoft that you can use. And these are the major links for you. I'll bring both of these up real quick so you can see them. So the first one here, you can see Azure Quick Start Templates. This is kind of the architectural view of it. You can kind of, click into these and it'll give you a lot of details, around them specifically there. If you want to, though, you can also go to the other link, which I'll click through here, which is the GitHub page. It's maybe a little bit easier and quicker to kind of digest these, if you're familiar with GitHub. And they're all here, and you can kind of see them as you scroll down. There are loads and loads of them available for pretty much, any service you can think of. Microsoft has probably created some sort of ARM template for it. A lot of people will start with virtual machines. So if I do a little find here real quick, why my search is not working, it's still loading the page. Let's find a VM one here. Multi-VMs Windows as an example. Let's click this one. And if in doubt, go to Chrome. Let's try it again. Okay, yeah, Azure deploy JSON. There we go. So he has an ARM template here for multiple VM deployments.
Not an Edge, folks.
Yeah, there you go. I don't know what's going on with Edge though, right? I think it's a problem between the chair and the keyboard, but we'll see how we go. So that's kind of the quick start templates. Before Cooper kind of gets into the demo for ARM, it's key to understand there's some specific file types that you need. So you've got an ARM template file. This is the file that describes the configuration of your infrastructure via a JSON file. You'll see the syntax shortly. You've got an ARM template parameter file. Now, this is an optional file. You don't have to separate out parameters unless you want to, but if you want to separate them out and plug them in, you'd use a parameter file for that. And then finally, just because you've got the JSON template and the parameter file, you do actually have to be able to deploy it. And there's deployment scripts, or you can use PowerShell to deploy it. You can use the REST API to deploy it. There's multiple ways to actually, go about and deploy that. Within the ARM template itself, then we've got, so this is the JSON construct we're talking about now. You'll find there's parameters. So these define the inputs that you want to pass into the ARM template. So during deployment, you might have a VM name or a password or something you want to pass in. Common sense, you'll have a parameter for that. Variables are values that you can use throughout your template. These are, you can create values in there that you can be used later on, when you call back to them. So say you create a resource group, or you can have a variable that declares one, and then later on you refer back to that. Resources, define the resources you wish to deploy or update. And then outputs are only needed if you need to return values from the template itself. Say, for example, one ARM template has a output of it might be a public IP address that you might use from one of your services that then needs to get passed into something else, maybe part of your workflow, maybe if using Jenkins, VSTS, etc. So with that, I'll pause for any quick questions. If there aren't any, then I think we'll hand straight over to Cooper and have him kind of give us a bit of a tour of the ARM templates.
Let me double check the feeds. Nope. Everybody's eager to hear, eager to see.
All right. Well, Cooper, I will pause it. Do I need to give him control, or
let me
another 10%? You got it.
I got it. Coop, it's all you.
All right. Let me know when you can see my screen.
We can see your schema.
Perfect. Okay, so the first template that I have here is just a pretty basic template that's going to create us a virtual network within Azure. So we have our different components of the ARM template already specified. We have our parameters section, our variables section, our resources, and our outputs. So in this case, what we're doing is defining a default value for this virtual network name. This allows us to not have to pass a parameter in every single time we create a virtual network, or every single time we utilize this parameter. For our variables, we just have both of our subnet names defined. These values can be used throughout the entire template over and over. And then our resources section is just made up of our single virtual network, which is defined here by the type. We give it a name. And then we also can specify the Azure region. In this case, what we're doing is actually dynamically grabbing the resource group location to ensure that our virtual network is deployed to the same region as our resource group. We're defining just a few values here, just the address space, just giving it a CIDR there, and then our 2 subnet spaces along with our names. You see here, these values are hard-coded, so you don't necessarily have to deploy all of your values as a parameter or a variable. They can be hard-coded in your templates. And then finally, in the output section, we're just going to pass back a string, just the virtual network name that we created. Couple things that are important to note here. For each resource type in our ARM templates, there's an API version section. So with every update that Azure does to their API, there's it correlates to multiple different resource types. So what this means is I can't just grab the latest API version, whatever that may be. That might be 2018 0801. Just because I grab whatever the latest API version is, that doesn't necessarily mean that there was an update to the Microsoft.network/virtual networks resource type. So it's important to make sure you're aware of this, paying attention when there are updates. That's how Azure will release the new feature sets and allow you to actually interact with those via your ARM templates. So in this case, I'm using a quite outdated API version, but we're doing just some very basic things here, so it shouldn't be a problem. So let's go ahead and deploy this template to our Azure instance. My preferred method of deploying ARM templates is generally PowerShell, but there are a couple different options, and I'll show you one of the other simple options here in just a minute. But you can actually deploy ARM templates via the portal. You can store some templates in the portal. You can integrate with other orchestration tools, other Azure Automation tools like the Azure Automation, Azure Logic apps. There's so many ways that you can integrate your ARM templates with other orchestration and automation tools. But what we're going to do here is just deploy it from our local computer utilizing PowerShell. So I'm just going to use the new -Azure RM resource group deployment. This is the out-of-the-box script that will deploy an ARM template to a resource group. All I'm defining here is a resource group name, vBrownbag1, a mode, and a template file. The mode here is important as well because there are 2 options for your mode that can be incremental or complete. An incremental deployment will allow me to deploy multiple ARM templates to one resource group without affecting the previously created resources. However, if I switch that mode to be complete, any resource that is in that resource group and not defined by this current template that I create will be removed from your Azure subscription. So that is very important to be aware of to ensure that you're not accidentally removing these resources that you didn't want to remove. So we'll go ahead and just click enter on this. We'll flip over to our Azure subscription. I'll go into my vBrownbag 1 resource group, and we can see under our resource group we have this deployment section, and we see one deployment is currently in progress. This will give me the current status of my template deployment, and it's already happened so quickly that it is completed, or it thinks it's completed. Yes. So now we have that Cooper's Cloud VNet. If we go into our subnets, we'll see both the CC subnet 1 and 2, along with all of our parameters and values that we input into our template. Now that's a pretty basic template, so I'd like to show one that is a little bit more in depth. And I'll start with the parameters file that we're going to pass to our template. So parameters file, as Nick mentioned, this allows us to store multiple copies of the same template with varying values. So the most common explanation for this is maybe I want to utilize a standard template to deploy all of my virtual machine resources. I can utilize parameters file to choose a separate virtual machine name every single time I deploy that template, and then I can just store all of those different parameters files in my source code or just in my folder where I'm storing my templates. So in this case, I'm going to pass just a couple values that are relevant to my virtual machine. I have a username, I have a password, and a VM name. Here for the password, we're doing something a little unique where we're going to go out and grab a secret from an Azure Key Vault. So this is a really nice feature because it allows me to store my parameters files without having a hard-coded password directly in my in my source code that's passing around and being used by multiple teams. And this method allows me to just store my secret in a key vault, and then our key vault access policies will let us enable access for template deployment. If we go in here, I'm not authorized because I'm on a different account, but there's a secret called admin password. So let's go ahead and deploy. First, I want to show what we're going to deploy.
I'll just say that Key Vault feature, just across everything, I recommend people use it. Just in Terraform, I've heard of people kind of checking in their service principals into public GitHub, and then within like 10 minutes or something, people are deploying things in their Azure or AWS subscriptions, and I don't know, maybe Bitcoin mining or something, but golden
You'll
lesson.
Never know.
Yeah. Never ever put your passwords in your automation templates. Golden rule.
Absolutely. So this is just a quick diagram of what I'm going to deploy with our next template. I have kind of this in-tier deployment where maybe I have an application that needs to run on a server, maybe it's running IaaS. And then on my back end, I'm going to use an Azure SQL database. And then I'm also going to deploy a storage account that will serve as the diagnostics storage for my virtual machine. So every resource that we see here is going to be deployed with one single template. The virtual network, subnet, NSG, everything is going to be deployed with one template. So if we take a look at this template, it can get quite overwhelming when we get into deploying multiple resources. You see here we have a storage account, then we have a virtual network, and up above we have our virtual machine. So as you're going through and building out your templates to be as dynamic and all-inclusive as possible, that template can get hard to read, and that's where you can actually utilize nested templates, where you're basically calling one template from within another template. This gives you kind of a little bit more organization to whatever it is you're deploying. But if you take a look here, we're just going to pass in a few parameters. Some of these parameters are not necessarily hard-coded, but they have default values specified so that I don't have to deploy them, or I don't have to specify them at the time of deployment. And then finally, this time I'm going to use a little bit of a different script. Rather than using that new -Azure RM resource group deployment script, I'm going to use the deploy-Azure resource group script. This one is provided in the Azure Quick Start Templates GitHub. And the nice thing about this is there's so much logic behind it into some really simple things like if my resource group doesn't already exist, it's going to go out there and create a new resource group. It will do some validation prior to even starting the deployment. It will allow me to do things like upload my template to an Azure storage account during the time of deployment. I generally recommend utilizing this script because it gives you so many more options during that during your template deployment. So we'll take a look, remove some of this chaos. Going to go into my file location. If we just take a look, we have a folder here for our parameters. We have our base Azure deploy, which is our template file, and then we have that deployment script. So we'll just paste in this deployment script, and you see there's a couple different things here where I'm actually specifying the template file, the parameters file, and then that resource group name and location. This resource group doesn't currently exist, so it should create as soon as I click enter. And you'll see there at the top, my vBrownbag 2 resource group is now created. And then as opposed to the previous script, this script is going to give me a verbose output of exactly what's happening during this resource provisioning process. Since that one does take a little bit of time, take a look real quick and see if anything's come in. Not just yet, but I have.
Like the cooking show, you've got one already baked, right?
Absolutely, already have one prepared.
Here's my quiche.
So if we take a look, this will look similar to our diagram that we just saw. We have our diagnostic storage account, SQL Server, NSG, public IP, and then our virtual machine with the NIC and OS disk along with our VNet. So we've now created basically this in-tier architecture with a server front end, Azure SQL backend, all with the click of a button. And if we take a look here in the history, you can see that that only takes 6 minutes total to deploy, which is so much quicker than going through creating your resources manually. And by defining my resources with infrastructure as code in these ARM templates, I'm ensuring that I have consistency. I can do things like set custom names to all of my different resource types. There's just so much more flexibility than going through and clicking, creating a resource in the Azure portal. Take one final look, and we're still prepping. Any questions before we move on to the next section?
One moment, let me check. No comments about cool and neat, but no actual questions.
Okay, perfect. I will stop sharing.
right, so I think, Chris, you have to give the ball back to me, right?
I do. 1 moment, sir.
All right, show my screen.
There we go.
Turned off presenter view now, so hopefully this will work even easier. There we go. Okay. Yeah, so I just wanted to reiterate a couple things Cooper mentioned, because like you said, the templates can get, pretty complex as they get bigger and bigger. So you do have the option to link templates, right? So you essentially, when you're linking templates, think of it like this: you'd still have your main template that you want to deploy from, but then you can have optional resource templates, a shared resource template. So if you've got a template where multiple people are kind of sharing resources from an ARM template, that's a method, or a member resource template as well. And this could also include, reusable scripts or custom scripts and things like that as well. So essentially, you've created your main template. If you look at it, and there's two main methods: inline and external. So an inline link-in, you essentially create the entire ARM template in the body of the existing template. Not a huge fan of that as much, because that doesn't really get you out of the whole, hey, this thing is ginormous. But you can do it. You technically could create, literally declare an entire new ARM template inside of your ARM template. And you can see it here, like you sort of specify the API version, name it as a link template, a type would be deployment, and then the properties essentially is another ARM template. The most common method, there's the inline example kind of blown out, but the most common method would be more the external link-in, as you can see here. So you can actually link a template. It could be on a blob account, it could be on GitHub, however you want to kind of decide to do it. But essentially, in this case, you see they've got the incremental, the same option Cooper kind of mentioned when he's doing the deployment. But now we link in another template with a URI that's linked in here, and this is just another entire ARM template that's included inside this ARM template. And you can also link parameters as well, as you can kind of see on the screen there. So I think that was just the last bit to kind of recap. And next, we'll kind of pivot though and think, okay, well, ARM is already very cool. Why would I want to kind of look at Terraform first of all? Well, I think a lot of people probably heard of HashiCorp Terraform. It's gained a lot in popularity. There's an open source version which is completely free to try. So everything we're going to do here is using the open source one, but they do have enterprise versions as well. The one major reason I'll tell people is if you are in an organization where you are expected to do perhaps AWS, Azure, and Google, each of them are their own, entire area to learn in themselves. I wouldn't say just because you know one cloud, you know another. But when you have to learn CloudFormation as, say, one way to deploy into Amazon, and then in Azure, you've got to learn ARM, and in Google, you've got to learn their language. This is a way to kind of unify at least the language that you use it. Not that it abstracts the clouds away. It doesn't do that, but it does make the language a little bit more digestible. The other big thing is it's just a little bit easier to understand and read, as you'll kind of see. And they have a very unique approach, to infrastructure as code and IaaS in the example I'm going to show you here. So when we think of the approach with Terraform, you have this concept that you'll see called Terraform Apply. You sort of go and you define your resources that you'll kind of see. So you got like a SQL server, your monitoring metrics for them, your service registry. This is using Console, which is another HashiCorp product. Perhaps your AD credentials that are stored somewhere as well. Then Terraform basically takes that information. It will go and create all of those objects. So the monitoring rule, the service registry entry we put there, and it will apply the AD admin. Very similar to ARM in that method. The dependencies are kind of automatically mapped for you. And then all configuration changes are saved to a Terraform state file for day 2 utilization. And that's really the major benefit. While it is possible to do some of that with ARM, it's not as easy as it is in Terraform. And so if you think about it, well, day 2 comes along and I want to modify this, this monitoring rule, if you will. And I want a very easy way to know what's going to happen, what's going to change, how's this all going to work. Well, Terraform then takes you update your code. Oh, I jumped ahead there. You update your code, and then what will happen is Terraform, you do your plan and apply. It will go ahead, look at the current state. It actually will go out to Azure, look at the current state of the objects provisioned in Azure, not just what your system's telling you that, right? It will actually validate them. And then it does the following. It detects the changes. Okay, update required for monitoring, and goes ahead and makes that change. So when it comes to modifying templates over time, day 2 operations, that's where it really starts to shine. The other way to think about it is compare it to configuration management tools, and it doesn't replace them. There's still a need for Puppet and Chef for your OS configuration. Terraform and ARM, for that matter, as well, really focus on infrastructure automation, VM, cloud provisioning, cloud service provisioning. But the good thing is they are declarative like your configuration management tools, but they fall short when you get to OS configuration. Puppet and Chef, on the flip side, great for, hey, I've got a Windows system, got a Linux system, I want to configure this certain way, I want registry keys like this, I want settings this way, I've got security hardening to do. Great, let me declare all that in Puppet and Chef, and let me also use Puppet and Chef for deploying applications that, that I'm, as part of my CI/CD pipeline, perhaps. Declarative as well, good for app install, not very good for infrastructure automation. And so when you marry the two of these together, you get the complete picture. You've got Terraform for your infrastructure automation, and when you've got IaaS services like VMs involved, Puppet and Chef, great for your OS configuration. And one other thing to keep in mind also, when we think of procedural versus declarative, this is really important. When we think of Terraform and ARM, they are declarative. But if they were procedural, like if we deployed something with PowerShell or the CLI, we have to go through the series of steps of connecting to Azure, creating my VM, installing the OS, or maybe doing it from a template, configure my NIC settings, install software package A, install software package B. In declarative, we're just defining the end state. We're saying, give me the following. I want a VM, 2 CPU, 2 gig, that would map to a size, obviously you would choose an OS, a NIC, and a chef role. And then it's going to figure out all the dependencies to get you there, especially when you have multiple services, involved. Quick, I'm going to flip through this pretty quick because I do want to kind of make sure we have time for demos here. But the main use cases, infrastructure deploy, obviously, multi-tier application install, self-service kind of speak for themselves. I will say a big thing of this is software demos and disposable environments. One of the big things, I use this for in my job every single day. When we want to set up an environment for somebody, we'll check out a Terraform file, deploy that, sets up the environment, we can show it, and then we can destroy it immediately after. It's also good when you want to share resources in a resource group, perhaps, and you've got use cases for that, and you don't want to, delete the resource group to destroy all of them. With Terraform, you have the ability to just do a destroy. It's just going to destroy the resources under its management. So it gives you that sort of way of, getting more, granular management of the services you deploy. And then, as I mentioned at the beginning, multi-cloud deployment is a, great use case, as well. The concept is very similar. So if we think of, Azure, you got this provider concept, and Terraform has the same thing. There's providers, and the great thing is Microsoft will hands down tell you that Terraform is a great way to deploy. Which is something to be said for the new Microsoft, obviously, in the last few years that everyone's talking about. They treat Terraform as a #1 citizen. When they release a new provider for Azure, they are working with Hashi to make sure their providers are up to date. I'm not saying it's 100% because it definitely isn't. Not every single thing is there. But if you go to the Terraform providers section, in fact, I'll just pull up the website. When you go to terraform.io, which is the main website there. There is a getting started guide here, which is really good. I highly recommend you go through it. But if you go to the docs section on the top, and then on the left-hand side, you'll see this piece called providers. Select this, choose your cloud provider. So let's say we pick Azure in this case. And then on the left-hand side, you'll see all the different services that it supports. And they have examples on the right-hand side as well. So if we were trying to do, let's say, an Azure SQL Server, we could select that. And here is the Terraform code for deploying that. If we were working with Azure Key Vault, similar kind of thing. And virtual machines, obviously very common for a lot of people. So I'll just scroll to the bottom or see where they went.
Nice.
Machine. Maybe it's VM, I forget exactly where it is. Azure ARM Virtual Network. Web Apps Compute, that's under Compute. There we go. So Azure ARM Virtual Machine. There you go. Yeah, so yeah, I agree, Chris. It's sort of super easy to kind of navigate, right? So, so if we go back to this quickly, so we've got providers and we understand those. Well, the next thing you need to understand are resources. So very similar concept. You declare your resource that you want to provision in Azure, and you'll see this kind of naming structure they have. So component, provider, type, name. So component is what do I want to provision? So in this case, I'm going to provision a resource. My provider is Azure RM. So one thing just to note here, is Microsoft did convert to this whole ARM resource provider model a few years ago. It used to be what they refer to as classic. You shouldn't encounter it much, but if anyone has questions on that, let us know. Everything we're dealing with here is we consider ARM, and that's the only way to provision if you're in Azure today. Then you've got your type. So in this case, a resource group in my example here is the type of resource. I might be provisioning an Azure resource group or a storage account or something like that. And then this is the actual name that I would give it in Terraform, not the name it's going to be in Azure. This is the name I can reference it throughout my code in Terraform, as you'll see very shortly. Then I decide on my execution. What I do is I do Terraform plan when I want to see what's going to happen. When I want to execute, I do Terraform apply. And then when I'm done with it, I do Terraform destroy. So it's this sort of iterative approach. If I change something and I do a plan, it'll either update that resource if it can, or it will destroy it and rebuild it in the apply stage. But the plan will always tell you, what's basically going to happen. In order to do this, though, to authenticate, you do need a service principal. And if you're not familiar with service principals, if you go into Azure, in Azure AD, there's an area with app registrations that you can do. And this is where you create your own security identity that's used by services such as Terraform. So you would go in, you need permissions in Azure Active Directory to create an application registration, creates a key as part of that, and then you assign that application to a role. So in my case, if I'm going to be building lots and lots of things in Azure, I would need the contributor role for a subscription to be able to assign, to be able to build in that subscription. Then I basically give Terraform this service principal. Terraform logs in as the application, and it executes tasks such as, deploy VMs. So I'm going to jump over to a demo here as well, and kind of just show you kind of the very basic constructs of.
Before you do that, real quick, we have a question.
Yeah, go ahead.
Stephen is asking, I have an Azure on-prem developer node, which I intend to use to prove out automation before we potentially invest in real Azure. Do you know if there are any issues with the Terraform provider for Azure and the developer node, which is not necessarily the same as the full-featured Azure?
Yeah, so just to confirm, are you referring to, and I hope you can reply in the chat there, an Azure Stack developer node, like the single, I think it's even a red box they give it to you in.
He said Azure on-prem. He said yes. Yeah, he said he's right.
Okay. So the only difference you will find is not all of the providers are in Azure Stack. It's designed as an on-prem version of Azure, but it doesn't contain all of the Azure services. But I believe that you can create a service principal in there or authorize it there, and you can connect to it that way and deploy into it. As long as it shows up as a region would be the only thing we would have to figure out. You might have some customization to do. So I guess the real answer is I don't know, and I've never done it. I don't see why it couldn't work, but I'd have to get back to you on a kind of more concrete answer on that. The other option would be just get a free trial account for Azure, just like the $200 credit they do, and try that out if you want to kind of try that out on Azure specifically, and then we can certainly try to get you an answer on the Terraform question for Azure Stack, that is.
Cool. Thank you.
Yeah, no problem. So the way Terraform works is you essentially have these files, they .tf for Terraform files. So you'll have like a main file. So in my example here, I'm just going to create a resource group first of all. I'm going to give it the name vBrownbag. I'm going to put it in location. This is where answering that question. This is the only part I'm not sure how it would appear in Azure Stack, but this generally aligns to the regions that you have in Azure. And then I can assign a tag to it. So you can already see that the code is much shorter, cleaner, probably a little bit easier to read than some of the things that you'd have to handle, because Terraform takes care of a lot of things for you. So if we go into that bit of code, I think it was on module 5. Just make sure, yep, module 5. And I do Terraform plan. What it will tell you right now is what's basically going to happen. So you can see the green plus you get, it's going to add a resource group in East US. The name of the resource group is vBrownbag. It's going to add a tag, owner, tag.owner with Nick Colyer. And then what I would do is do Terraform apply. It'll ask me if I want to go ahead. Type yes. And it will go ahead now and provision that resource group, and that's created. So if I go over to my Azure account and refresh here, we should have a vBrownbag resource group there. So very, very basic thing, first of all. But before we kind of expand on that, there's a few other files that you can basically see in here. And essentially, When you decide you want to connect to Azure, this is your authentication piece right here. So subscription ID, client secret, and tenant ID. So I always encourage people, the first time you create a Terraform file, just go ahead and do something very basic like creating a resource group to make sure that you get all of this configured correctly. I'm not going to go into the TF-vars file. All that file has is the actual values for this. Again, that's like putting your keys to the kingdom out on the public internet. But essentially my secret and all the variables that map to this are stored in there, and I have a git ignore file on that for the purposes of this demo. But the benefit would obviously be to use Vault or something else to kind of truly kind of manage that in an enterprise environment. So then if we go and expand this out, and let me go into maybe another module we've got here, let's see what additional things we want to add. So another one here. So similar concept. I've got a resource group. I'll call this one vBrownbag 1. Sorry, technically it's 2 now. East US. We've got a variable prefix. You can declare a variable. In my case, I'm using a prefix and I'm saying SL, which stands for Skylines, just when I did these demos. But where I can use that is now when I want to name things. So I've got my resource. So the first thing, if we remember how we declare everything, I'm saying I want to build a new resource. It's of type Azure RM Virtual Network. The Terraform name I'm referring to it at is main. This is my main network. And my name in Azure for that network would be SL, because that's our prefix that we're referencing right here, and dash network. So it'll be SL-network. It has the address space, very similar to what you saw Cooper create earlier on. But then I get some additional things that make it a little bit easier. So like location, which location do I want to put this in? Well, do I really want to go through and say East US for everything? Perhaps if I was deploying something in multiple regions, I would want to specify. But in my case, I'm saying, well, look at the resource group I'm deploying into. The resource group named resource_GP, which is the one at the top here of the screen, and use its location. So I'm just saying, use this resource group's location. Same with the name here, because when I build a new network, I have to actually specify the name in Azure, use the resource group's name. So I don't have to go in and type and potentially fat finger a lot of things. I'm just literally just referring back to these variables at the top here. Same with things like the subnet. Well, I'm saying, okay, I've built a network. I want to build a subnet inside there. Well, which virtual network do I want that subnet to be part of? Again, I can just refer to the virtual network construct. It's main, that's the name of it. Again, I could call that whatever I wanted to, as long as it's consistent. If I change the name up here and I wanted this subnet to go in that network, I would need to change it here as well. And then, saying to it, I want to put it in main.name, that network. And you'll see that throughout the configurations. Then we've got things like virtual machine itself. So again, here I've got a resource declaration, Azure RM virtual machine, name of main. I've got my prefix, this is going to be SL-VM, same location, same name, etc. on there, and here's the size I've chosen. A few other things you can do here as well is delete OS disk on termination. So you can choose to comment or uncomment this line. Essentially, this is how it was when you download the code from Terraform. This is just to point out, this entire template I'm showing you here is something I modified that also comes directly from Terraform's repository, and there's a whole community repository of Terraform code as well. But I can just uncomment this line, and then when I delete the virtual machine, it's going to delete the disks as well. Same with the data disks. So this gives me an option for, hey, I'm deleting the machine. I want to make sure everything gets cleaned up with it. Very easy option to do that basically. So got all of that there. Now I do the same thing. If I go over to, we'll just go over to module 6 here and do a Terraform plan again. And you'll see here it's going to add a whole series of resources. So checks Azure, looks at what's there, and it just gives you this really great list of everything it's going to do and all the values it's created for it that you don't have to kind of come up with completely. It's, figured those out for you. And then again, if I do a Terraform apply, that will go ahead now and start building out. Let's wait for this to update. So I'll have to give it the yes. And off it goes. So while that's going, what you'll also see is there's this file called tf.state. And you can actually see that lock file currently got locked there because it's busy doing things right now. So it's saying, you know, the state is currently locked because Terraform is doing something to it. So it stops you know, not two people open at the same time. So you can see that they're unable to open. So I'm just going to go back to the other one while that deploys. So we'll go back to module 5. And if we go to main.tf, so this was the one we deployed with the vBrownbag resource group. And if I go to terraform.tf state, this will actually show you the current state of this environment. So this is essentially what Terraform is expecting if it goes and looks at, you know, Azure to kind of see basically. And this is a way, like, you know, state management becomes a thing, because this is saying this is essentially the state of your environment. So every time something gets updated, you know, it saves it to the state. You can do things like remote state. You could Terraform Enterprise has a way of storing state for you. If you don't want to keep it just on somebody's local machine like I've got here, that's something that becomes important if multiple people are kind of working on the same set of Terraform configurations there. The other thing to show you very quickly as well is what if I go ahead and make a change. So if I call this vBrownbag 2 now in this particular one, and let's go back to, I think PowerShell's still busy there, so I think I can open another terminal window directly in here. And I'll do a plan again. So it's refreshing the state, and you can see that because I'm changing the name of a resource group, now in Azure, you can't just go in and rename a resource group. It actually tells you this forces new resources. It's telling you that that action in Azure requires new resources. And you can see here, it's showing you each individual piece. So the location, well, that didn't change, so that's not causing me a problem. My name changed, so that forces new resource. Same if I went in for West US and did a plan, we should see something similar there, where the location would also force a new resource. And both of those now force a new resource. So it gives you a very easy way to see, okay, I want to do this thing, but what's actually going to happen? In this case, it would add a resource, but it would also destroy the existing resource for us as well. So if I went ahead and did Terraform apply there, so even though I've just done a plan, it will always check the state one more time whenever you do your apply. So it's basically destroying that resource group now, and that will take a moment, and then it will create that new one. And it looks like this one is completed, so we will go over to Azure, refresh what we've got here. So we still have the vBrownbag. Oh, you know what? I don't think I changed the name, so I think it's actually Skyline's Demo 6.
I think it's Demo 7.
Yeah, let me go back here. That one's busy destroying still, so we go Skyline's Demo 6. And we should see in here all of those resources being created. So we've got a VM, a NIC, network, and a disk in itself. The last thing to show you, while we kind of got, you know, we've got destroys and everything going on in parallel here right now. In fact, yep, that one's completed. So let's go back one more time, refresh those resource groups. And you can see that is now vBrownbag 2 in West US, but it did actually go ahead and, you know, destroy everything, you know, that particular resource group. So what I was going to say is, yeah, the last thing to show you here is, well, how do I kind of organize all these files, and what happens when I want to add multiple services? So I'll show you one of the kind of fully complete ones that would take a long time to deploy, but if we kind of look at this, you can see I've got this main TF file where I've got you know, still got my network, my subnet. Let me expand this down a little bit, similar to what you saw there, but perhaps I want to add a SQL service, a separate one, like an Azure SQL service, but I don't want to actually build a VM for it. We just created another piece in here with another TF file. As long as I just put it in the same folder, Terraform treats this as one configuration. So it's looking at the folder and saying, okay, I'll take the DB code and the main.tf and all my variables. Okay, what do I need to actually build here? And now I can just declare my SQL server, which is here, my resource for the network rule and the subnet. And this is actually a virtual service endpoint in Azure. So for anyone not familiar with it, when you have service endpoints, like you can see here and in this network rule, that's taking a public service, a public peered service such as Azure SQL, which could be publicly exposed, and actually takes that network and isolates the Azure SQL service to that specific network. So it's just a form of isolation and security that's kind of enforced at that point. But essentially now, as long as I've got all of this in the same folder, it would do a plan as if all of this is one giant, giant configuration, basically. So with that said, let me see if I had any other slide. No, that was it for the slides. So that really concludes what we wanted to go over. Unless Cooper, you got anything else to add? Otherwise, we'll turn it back over for questions. I think we're right on time here.
Nice. Let's see what we got for the question boxes. Nothing locally. A comment about how amazing it is how quickly VS Code has become the de facto IDE.
Yeah, that's so true. Everybody brackets and all of them, and it was interesting. Cooper had the white theme. I've stuck with the dark theme, but after watching him use it, I'm like, his is actually way more readable than mine. So.
just for demonstration purposes, not for actually having it in the I'm still on dark theme.
Dark theme, okay.
Yeah. But seriously though, everybody and their grandmother is using VS Code nowadays. It's crazy. Yeah. Okay, back to you. Let me see. Check TweetDeck. A lot of thank yous, but yeah, no questions. We're good.
Okay, awesome. Well, yeah, we don't have anything else. So thanks everyone for attending, and yeah, hit us up on Twitter, and we love the stuff, and hopefully this was useful for an hour. We have proposed to the Brownbag team, maybe we'll do kind of a deeper dive on one of these two. We thought an hour we could kind of do 30 minutes on each. So we'd love to hear what what you want to see as well. So.
Definitely, yeah. Let's talk about that offline, because there's a bunch of different things that I personally would like to see. Let's see who else. Somebody said VS Code is greater than Atom. Yes, that is. There you go. That is completely accurate.
I agree.
That was Stephen again. Good job, Stephen. Cool. All right. Well, in that case, gentlemen, thank you very much for presenting this evening. This was absolutely fantastic. I was not disappointed. I told everybody I was excited to do this one, and you guys totally lived up to it. This is awesome.
All right, well, thank you. We appreciate it. Thanks for having us on.
Great. Absolutely. Everybody, have a wonderful evening, and we'll see you again soon.